Hello, everyone. We're going to do some practice problems for the PPC or the product. Let me try again. Production possibilities curve. So you should have the same worksheet that I have in front of you, and we're going to just work it out together. We'll go step by step. And if you can go faster than I can and you're bored, that's okay. You can try and do it by yourself, and you can pause it and then come back and check your answers at the end. But if you'd like that step by step, let's get to it. So question number 1 says, the table below shows the production possibilities curve for this country, California. Use the table below and do the following. So A says draw and fully label a production possibilities curve. So I'm going to start by drawing my X and my Y axis. And then when we draw any chart, we have to make sure that we fully label it. So I'm going to put capital goods over here, and I'll put consumer goods at the bottom. And then let's go ahead and make ourselves a scale. So this will be 0, and we need to get for point G up to 35. So I'm going to try going maybe in increments of 5. So let's go 5, 10, 15, 20, 25, 30, 35. And again, we have to mark what we did. So 5, 10, 15, 25, 30. And there we end up at 35. And then we'll do the same on the bottom. And we need to get to 45. So I'll go by 5s, 5, 10, 15, 20, 25, 30, 35, 40, 45. And label them out. If at any point I'm going too fast, you need to pause to do it on your paper. Just pause the video and then you can keep working. Okay, so now we're going to plot these points. So point number 1 is here, and we're going to label that point A. So I need to go to 0 on the capital goods. I'm going to change color so we can see it easier. We'll make them red. So I'm going to go to 0 on the capital goods and then 45 on consumer goods. So that means I'm going to put a point right here, and I have to label it. That is point A. Next, for point B, we're going to go to 10 and 42, which puts me right about there. We'll call that B. 18 and 39 puts me up here. Notice that all of these guys seem to be pretty close together to start. And that's normal because usually what we see is a pretty sharp decline in the curve once we get towards the end of it. So here's point C. D takes me to 20. Nope. Yeah, D. 25 and 33, which puts me right about here. There's D. And then E goes to 30 and 25, which is here. F is 33 and 15. So here. And then way over here at point G, oh, I did label these, E, F. Then way over here at point G is 35, all capital goods, and 0 for consumer goods. So now I have all of my points, and then I'm just going to connect the dots. Poor little E, I left him out. I don't want him to be lonely. We'll just make this a really fat curve, and that's okay. Doesn't have to be perfect, doesn't have to be beautiful. Okay, let's see what we've got next. So next says, plot the combination of 20 consumer goods and 40 capital goods. So I'm going to add, that means we're adding this little point right here. We want 20 consumer goods and 40 capital goods. So let's see where that point takes us. If we are at 40 consumer, that's here. Nope, 40 capital, which is up here, and 20 consumer. So that's going to be, let's go back to red. That's going to be this point right about here. And it says label that point X. Okay. Now that right away is going to stand out to me and say, well, why is that point not on the curve? That's probably got to mean something special. And it does. And we're going to get to that question in just a minute. And then the next one we're going to do is 25 on the consumer goods, which puts us here. We're going to start here and then go up to 20 on the capital goods. So this point here, and we're going to label that point Y. Explain what is happening at each of these points. So now we have to talk about it. So I'm going to put my answers up here in this little bit bigger area. So what is happening at point X? Well, any point that lies outside of the curve is mathematically impossible. It's not, it's impossible, because given the resources that they currently have in this fictional economy, Cliffordonia, there is absolutely positively no way that they could produce goods in that particular combination. It's outside of the production possibilities curve. So let's say it's outside the curve, which means it's impossible. Okay, what about point Y? It's under the curve. So what do we know about any point that's under the curve? Under the curve means you're a big old slacker. That means somebody is not using their resources to their fullest potential. Maybe we have a lot of unemployment and there's people that could have jobs, that could be working, that could be producing things, but they're just not because they're unemployed. Maybe we have a giant warehouse full of computer pieces that someone wants to be a hoarder and they're not utilizing. But basically, any point that is under the curve is a point that we are going to call inefficiency. Ooh, can I spell inefficiency? I bet I can. And if I can't, well, there's nothing you can tell me about it because I can't hear you anyways. We're just going to say that's how you spell inefficiency. That means that the goods are not being used to their full potential, because remember, any point that exists on the curve, point G, F, E, D, C, B, A, all of those points on the curve, those are what we're going to call maximized efficiency, meaning all of the resources are being used to their fullest potential. So any point on the curve, that represents efficiency. Any point under the curve, you're a bunch of slackers, it's inefficiency, the resources are not being utilized to their best capability. Any point on the outside of the curve, it's impossible given the current combination of resources, technology, manpower, all of those things. We can't do it. It's impossible. Okay, next. What happens if Cliffordonia produces combination A? Well, where is combination A? Here it is down here. So listen, economists are not like English majors. English majors like you to read between the lines and talk about symbolic language and put all these flowery things. No, economists want you to be cut and dry and state the obvious. So at point A, what happens if they are producing at combination A? Well, that means they are going to produce only consumer goods and zero capital goods. So what happens? They will produce only consumer goods, zero capital. Now remember, capital goods are goods that you go into making other goods. So they are goods that can be used in the production of something else. So you know, raw material type things are what go into capital goods. Consumer goods, that's like a hot dog, a slice of pizza, a pair of shoes, a calculator. You're going to use it, you're going to consume it, and then that's it. It does not have a second life unless somebody who's really awesome at recycling picks up a bunch of things from the landfill. Otherwise, that's it. We've consumed it. It's done. Okay. Next, what happens if they produce combination G? Again, we're going to be super obvious at combination G. All that means is they are producing only capital goods and zero consumer goods. All right, next, what is the opportunity cost of moving from point A to point B? Well, let's look. All right, I'm going to see if I can erase this little circle. Yes, I can. Okay, to go from point A to point B, we're going over just a little bit and up just a little bit. And this graph is a little hard to read because it's small, the scale's not very accurate. So we can also use the chart to talk about opportunity cost of moving from one to the other. Remember, when you move up the production possibilities curve, your opportunity cost is the things that are on the x-axis. So that would be the difference from going to here to here. So what is the difference? When I move from point A to point B, I went from 45 on the X to 42 on the X, which meant that my opportunity cost was, who can do math? 3. But 3 what? 3 consumer products. That's what we got. So when you're moving up the curve, your opportunity cost is the items that are on the x-axis. So 3 consumer goods. All right, what's the opportunity cost of moving from C to D? Again, we're going from this point up to this point. We're still moving up the curve. So our opportunity cost is going to be consumer goods. And we are going this time from C to D. So let's look here from point C to point D. What's the difference between those two things? Who can do math? It's 6. So our opportunity cost of moving from C to D is 6 consumer goods. All right, point F to point E. Now we're moving in the other direction. So let me erase this stuff that we did up here. Now we're moving from F to E, which means I'm moving down the curve. When I move down the curve, my opportunity cost is the things that are on the y-axis over here. So if I use the chart, now if I'm moving from F to E, here to here, it's again, the difference is 3, but this time it's 3 capital goods. What is the opportunity cost for moving from point B to point C? Wait, is that what we're doing? B to C? Okay. Here to here. So from B to C, again, it's 3. Now I'm going to add one for you. What is the opportunity cost of moving from Y to E? That opportunity cost is 0. It did not cost me any additional consumer goods to make a vertical shift upwards to maximum full efficiency to that point on the curve. So when you move from a point of inefficiency to a point of efficiency, the opportunity cost is 0. Okay, assume that economists in Cliffordonia are deciding between producing combination B or combination F. Which of these combinations will most likely result in more economic growth over time? This is kind of a trick question because we haven't talked about this yet. But here's what you need to know. Economists will tell you over and over and over again that when you focus your economy on producing capital goods, goods that are used in the production of other goods. So when you spend your time producing the raw materials, basically, that are used to make consumer goods, the potential for growth is greater. Why? Because you're using those goods to make more goods, as opposed to consumer goods, which you make them, they get consumed, that's it, their shelf life, they're done. Capital goods, you make it, and then somebody's going to take those things and make something else with it. So the potential to shift the curve and have more growth is significantly greater. So which are we going to pick, point B or point F, if we are looking for growth over time? Well, we then want the point that is closer, producing more capital goods. So F produces significantly more capital goods than point B does. So our answer is, if we want economic growth, we're going to pick point F. Why? Because that produces more capital goods, and more capital goods lead to economic growth over time. Good. Okay. Explain how the production possibilities curve shows each of the following concepts. Scarcity. Well, scarcity can be demonstrated on this curve because it shows you that there's a finite amount of resources. This point X out here, that point demonstrates for us oops, I gotta keep Y. That point demonstrates for us scarcity because you cannot make that combination of goods. Why? Because we are already utilizing our resources to their fullest potential, and there is no room to make anything else because we've already used all the resources. So point X shows us scarcity because I cannot produce that. There are not enough resources to make at that level. So point X demonstrates for us scarcity. What about unemployment? Unemployment would be an example of an inefficient use of resources. What resource? Human capital. We've talked about the fact that labor and human capital are part of the factors of production. And so if we have not enough people employed in the marketplace, then that is another example of inefficiency, because we're not using our labor resource to its fullest potential, because there's a lot of people that don't have jobs. And if those people did get jobs, they could produce more things. So point Y demonstrates for us unemployment. What about efficiency? We've talked about this a couple times. Any point on the curve demonstrates efficiency. We are maximizing the use of our resources, and we are at a point that economists call efficiency. And then opportunity cost. How can we show opportunity cost? Well, we just spent the last 5 minutes doing that. Every time we move from one point to the next, you have to give up something to gain those additional things that you just produced. So when I move from point G to point F, I have to give up some capital goods in order to gain some consumer goods. So that shows us opportunity cost. Economic growth. We just talked about that. If they're making more capital goods, the potential for economic growth exists. And if we saw a shift in the curve, which, newsflash, you guys haven't talked about shifts in the PPC yet, we're going to do that tomorrow, so don't stress about it too much. Okay, everybody good on those ones? Flip your page over. Let's go to the back. I just had a brain fart and couldn't remember if I was recording. And if I had gone through all that work and wasn't recording, I was going to be super annoyed. But I'm recording, so it's good. It's a little late at night. I'm ready for bed. Okay, use the PPCA. Here's PPCA over here. And PPCB to answer the questions. Okay, so let's go first with PPCA. Says, what is the opportunity cost of moving from point A to point B? So point A is here, and I'm going to go down and over. So what was my opportunity cost? When I move down the curve, I'm sacrificing things on the y-axis. So my opportunity cost for moving to point A to point B is... That's right. You got it right. Good job. 5 bikes. I'm so proud of you guys. I knew you were brilliant. I knew you could do it. Okay, moving from point B to point C on this curve, again, we're going to go here and then down. I'm moving down the curve. So I'm sacrificing opportunity cost on the y-axis. So shockingly enough, who can tell me what our opportunity cost is? That's right. It was the same as the time before. Again, it's 5 bikes. So then part 3 says, what generalization can you make? Economists are not looking for you to be super flowery in your language. Let's state the obvious. What generalization can we make? We can make the generalization that the opportunity cost is the same. That's right. This is like a linear equation with a slope where it's the same movement every time on the line. And I gave you a fancy word, a fancy term for that yesterday. Anybody remember what that was called? Constant opportunity cost. That's right. So generalizations can we make? Opportunity cost is same for each point. So it has a constant opportunity cost. The other assumption that we can make is that these are easily substituted goods. When you have a straight or a constant opportunity, no, when you have a constant PPC, production possibilities curve, that means that the opportunity cost is the same, it's constant. That tells us that in the real world, these two goods are very easily interchanged or substituted for each other. Think about it. Is there that big of a difference between a bicycle and a tricycle? Not really. I mean, you know, if you're 4, if you're 84, okay, maybe there's a bit of a difference. I'd probably prefer the tricycle if I was 4 or if I was 84. But for the general population, there's not that big of a difference between a bike and a tricycle. And so these are easily substitutable goods. Okay, we're coming into the home stretch. Let's look at PPCB, the opportunity cost of moving from point A to point B. Now I'm gonna zoom in just a little bit because that's a tiny little shift, isn't it? So we're going from A, which is here, to B, which is there. What is our opportunity cost? Again, we're moving down the curve. So that means we're sacrificing on the y-axis, and we are only sacrificing what? 0.5 or half a car. So our opportunity cost from A to B is 1/2 or 0.5 cars. Opportunity cost of moving from B to C. So again, we're going to drop down and go from here to here. And when we got from 24.5 down to 3, again, we're sacrificing on the Y, so we're sacrificing cars. So what's our opportunity cost? 1.5. Because how do we get from 23 to 24.5? We just add 1.5. What is the per unit opportunity cost of moving from C to E? Good news for you is that you don't have to do that. That's an AP level question. So let's go like this. And those of you that have taken the time to watch the whole video, don't you dare tell the other people in class who are sitting there like, oh, I don't know how to do number I. Oh, what's the answer? And you'll be like, oh, maybe you should watch the video. Oh. It's really late. I'm getting a little petty. Okay. Which PPC shows increasing opportunity cost? Give a numerical example to support your answer. Well, increasing opportunity cost means that the further you move along the PPC, the opportunity cost gets bigger. And we just talked about how PPCA had a constant opportunity cost. So by default, you could logic your way into this one, but the answer is B, the second production possibilities curve. And the reason is, as I move down the curve, the amount that I'm sacrificing in my opportunity cost is getting bigger and bigger and bigger. And so we describe that as an increasing opportunity cost. So to give a numerical example to support it, we could talk about how the change from A to B is only 0.5. But if we went from E down to F, then you're sacrificing 15 cars. So the opportunity cost has significantly increased just a couple of steps down the graph. All right, my darlings, that's it. That's what I have for you in terms of your practice. Don't forget that you do have a homework assignment. It's to watch the Monsters, Inc. econ movie and do the homework. That's also on production possibilities curve, but I know you guys can do it because now you're going to be experts in that field. So I hope you have a wonderful day. I will be back on Thursday. So lucky for you, only one more day you have to go without me, and then I'll be back on Thursday. I will record your lesson for Wednesday as well, and then on Thursday, you get me. See you guys. Oops, wait, that's not what I want. This is what I want. I'm going to end the meeting.